Hello, everybody. Welcome on this second day of First Ukrainian Distributed Ledger Technology Forum. Sergey, how are you?
Yeah, hello everyone, Ivan. Hello everyone. Yeah, thank you for joining us today. So yeah, this is the second day, and we are super excited to be here.
I was
Today
super
will
excited
be the interesting.
about 7 hours, about 8 hours of content yesterday, and I can't wait for the beginning of this day because there are lots of great speakers and presentations. Uh, I'm not mentioning my. I'm talking about other speakers, but
Maybe it will be the greatest one.
don't say that. Okay, so the stage is yours. Please present our first speaker. I'm going out of stage, and the stage is yours.
Yeah, thank you so much, Ivan. Dear audience, so we are starting from today. We are starting from paper defense sections. So you remember the format. People will be our presenters will be presenting the results of their work as a research for like a standalone project or just a research or a part of the project. So yeah, we are starting from Diana Sokolova and
Hello, my
yeah,
name is Diana Solovyova. I'm from Odessa National Polytechnic University, and I'm very grateful to the organization for this wonderful opportunity to perform today in front of such competent audience. So I will tell you about our work that presents development and research of a simulator to improve proof of work blockchain technology. This work presents a method of improving proof of work blockchain technology. To solve the problem of optimizing proof of work blockchain technology, the idea of dynamic grouping of nodes is proposed. It is proposed to use a simulator allowing to study the behavior of real blockchain network nodes compatible with additional configuration in order to realize dynamical grouping idea and to test hypotheses designed to minimize time spent on transaction in the system. So nowadays, the development on technologies is changing our perception in many ways, and of course, one of the essential direction is the development of blockchain technologies, which ensure the safety and reliability of digital transaction. However, along the expansion of this technology, it still has problems which need to be solved. One of the key mechanisms underlying blockchains is proof of work technology, and it has its drawbacks, the main of which is the large amount of time required to process transaction. Long transaction times in proof of work mechanism create challenges for the speed and scalability of blockchain systems. Long delays can lead to unrealistic user expectation, performance limitation, and low network bandwidth. For a dynamic consensus mechanism proof of work, there is no ready-made implemented decision that could be successfully used. And the static method proof of state differs from the dynamic one proof of work by a number of key features which demonstrate the differences in solutions that can be applied to them. Like, for example, a proof of state system has a list of nodes that can understand and we can understand which nodes are farther and closer. Despite proof of work system, the user doesn't see the entire network, and this information is not available. Secondly, in proof of stake system, this system stores a table of proof of stakes. So the matrix, despite proof of work, is more complicated and we cannot track users or measure distances. So these features significantly complicate the implementation of the clustering for proof of work consensus mechanism, and none of the existing algorithms implements the distribution of a proof of work network into subnets in order to minimize the time rate. The process is very complicated, really, and it is very difficult to find the necessary parameters for modeling such a network. So it is proposed to break a system into subnets or groups where the consensus is not accepted by the whole community, but only by certain groups. The primary task of this work is to model a system and to test the proposed hypothesis. One of the key mechanisms in this work is idea of dynamic grouping. The system is divided into subsystems, groups, and this division occurs dynamically. To do this, first the power of group is calculated, and then actions are performed to obtain the characteristic of the group, so they will be used for further clustering. So to solve the problem, we have a task to minimize the amount of time which is spent on the transaction. So we are going to split the system of proof of work mechanism, blockchain system, into subnets, where the consensus wouldn't be accepted by the whole community, but by the subnet. And we would get the improving of the operation of the proof of work mechanism. So we have the task of verification of formulated hypotheses aimed to increasing transaction speed. For verification, it is proposed to simulate a model of blockchain network in order to conduct experiments and to test hypotheses. The network model should be flexible and customizable. Why? Because that its parameters such as number of nodes, the distance between them, the strength of groups can be changed, and this will allow to run different simulation scenarios and analyze their result. So metrics characterizing the performance of the blockchain were analyzed, and our goal is to improve such metrics as the transaction per second, reduce transaction latency, and the first stage of implementation of this idea is the creation of the network model, which will allow conducting experiments and testing hypotheses. To carry out the necessary experiments and model blockchain network, it is suggested to use a network simulator built on a proof of work consensus mechanism with additional configuration that can be adjusted for proposed as hypothesis tested. So during the development, we should consider such characteristic of proof of work network. Firstly, number of nodes, of course. Analyzing total number of nodes in a network is an important factor in understanding the performance and security of blockchain systems. For example, a larger number of nodes helps to increase decentralization and to reduce the risk of centralizing control over the network. Secondly, computing power. More powerful nodes are able to perform more difficult work than solving complex cryptographic tasks to mine blocks. And the high computing power of the networks makes 51% of attacks more difficult, so each makes system more secure. And of course, we have to consider capacity of the system. So let's speak now about the design of a simulator, which was made to conduct our experiments. A blockchain network simulator consists of two components: the peer-to-peer decentralized network and proof of work protocol. This simulator software is implemented as a web application written in JavaScript programming language and consists of four main classes. Each of four classes is responsible for the components of blockchain network, and basically it helps us to ensure proper simulation of the network. First class is network. It encapsulates all other instances of the class and is responsible for maintaining peer-to-peer network layer parameters. Secondly, blockchain ledgers are stores in miner or node class and is implemented as an array of block header. Network buffer class acts as a router connected nodes, and a block or header class supports proof of work consensus layer option. Nodes are built with function for mining and broadcasting information. So this simulator allows to build network topologies in the blockchain and carry out various manipulations with them while recording their results. On the figure, we see creation of models of networks topologies in the simulator. This software has ability to save and to load network structure. This is achieved by converting structure to the user's file system on the local hard drive. A process of mining a block consists of repeatedly trying to find a unique nonce value in the block and hashing that header twice with SHA-2056 until the resulting hash meets a numerical lower bound or difficult threshold. Blocks are issued randomly, and the average duration between them is 10 minutes according to Bitcoin Consensus Protocol, which regulates the difficulty of mining. Now, let's speak about additional configuration we need to add to our simulator to conduct our experiments and get our results. To set the necessary configuration for System Simulator and expand the capabilities of Blockchain Network Simulator, let's analyze the problem of minimization transaction time in a network with a proof of work consensus mechanism. So, what should be taken into account? Firstly, field of view, basically possibility of weighting and table of distances. We calculate the group diameter, so maximum distance in the group must be less than or equal to the cluster diameter. Secondly, we should consider, of course, number of node connections, fully connected group nodes, and nodes with several connections. For each one of these elements, this is a separate case, of course. Then choosing a criterion. During the modeling, it's important to choose a criterion that should characterize our subgroups. A number of nodes are combined into groups, so-called crystals, while this criterion is filled. And now let's speak about the dynamic grouping algorithm, which is the idea for the solving of the problem with proof of work. The system is divided into subsystem groups, and this division is dynamic. Firstly, the system is initially treated as whole, but it will be divided into subsystem dynamically. This division on groups is based on concept of power of group, which is calculated for each group. The second step is calculating group power. The power of group reflects its ability to mine blocks and participate in consensus process. Next step is determining the center of crystallization for each group, making certain groups more profitable for nodes to join due to their high power. Then we have to set node transition rules. Why? The rules by which new nodes can join certain groups. For example, restrictions on the number of transition or other factors affecting the attractiveness of a particular set of new nodes. For example, transition to another group is possible no earlier than 10 blog publications for a certain node, or for example, it is not possible before 5 finalization for a node. Then we have to set also rules for joining new nodes. Also, factors affecting the attractiveness of a particular set of new nodes. Then we have to set configuration parameters that can be customized. We will speak about this more detailed later. And then we have to conduct experiments, of course. Experiments can involve changing the parameters like distance, power, and the transition rules to minimize the transaction times. Finally, testing network clustering algorithm to determine how groups are formed and organized. Now let's speak about the list of specific configuration parameters we have to set to our network simulator to reach our goal. So the first configuration is number of nodes and groups. We have to set like a variable for total nodes and total groups. Secondly, node power. Power expressed in hash operation per second or computing resources. Then distance between nodes, a distance metrics to define connections and distances between pairs of nodes. Distance expressed in hop count or transfer time. Then we have to set, of course, rules of transition between groups. Like we have to set basically a variable to set the minimum number of blocks of finalization the node must make before it can transfer to another group. And we have also to set rules for joining new nodes. Basically, variable to set maximum number of hops and new node can make before it can join the group, and the value of joining rules for each node or group. So, this study expands all previous possibilities of modeling the blockchain network. A 10x10 network model with 100 of nodes was created for the purpose of conducting experiments to test hypotheses to minimize time spent on transaction in blockchain system with proof of work consensus mechanism by realizing dynamic grouping idea. The simulator is currently being tested. First results showed the correctness of underlying algorithmic solutions. The idea of dynamic grouping will be implemented by establishing the necessary configuration in order to study how Lials affects the distributed consensus of the system as whole. The results will be measured in order to obtain the necessary conclusions regarding hypothesis testing. That's all. Thanks very much for your attention.
Thank you so much, Diana. So first of all, I have to apologize for incorrectly stating your last name at the beginning. Secondly, thank you so much for the great presentation. So there are a couple of questions. There is a question from the audience. Basically, the question states, what is the exact problem you are solving? If you can provide a very high-level description. So we are doing this for...
The problem is to minimize time spent on transaction in a proof-of-work consensus mechanism. To test our hypothesis.
Basically, you are... But please continue.
We test our hypothesis we have to reach this result, to minimize time spent on transaction in proof of work exactly by the idea of dynamic grouping, because in proof of state it is possible, and in proof of state time is less, but we try to solve this problem in proof of work consensus mechanism.
So basically, yeah, proof basically with proof. So you are working with proof of work to increase the scalability of it, and yeah, that's so basically your solution is applicable to the proof of work, but not to the proof of stake, right?
Yes.
Yeah, that's great. I also wanted to ask, there is actually a beautiful word you were using about crystallization. So I assume it may have been connected. We were, again, I'm also coming from research of the distributed ledger technologies. And when it goes about large nodes, clustering and crystallization, so you are assuming probably that the grouping is forming in a way how crystal is in a similar way how crystals is formed from the liquid when the temperature goes down. Is that correct assumption? This is why you are using this term.
Yes, like the idea is about.
Yeah, that's interesting. And also another question was modeling. So basically, is there a public or private access to the modeling you have done? So maybe somebody from our audience would be interested to check them, or maybe somebody can approach you in private and ask about these results.
It is in private now. It is my Majesty work, and I'm working on it. It is in process, but of course, I would be grateful for some interest to my work, for some help. I can show it in private for now, but when it would be finished, it would be published in public.
Understood. Thank you so much. Do we have any other questions? So let's wait for a moment. I think we don't have other questions. Diana, thank you so much for amazing presentation. You were the first paper presentation today, and yeah, I am welcoming to the stage the second presenter.